Hi everybody, welcome back to Under the Integral Sign. Today we're going to be developing a new integral formula for this integral right here. And we will be using the Leibniz rule for differentiation under the integral sign, of course. All right, so let's get started. So we're just going to call that integral a function of a. And we can think of that as a function solely in terms of a as long as we consider b to be an arbitrary constant. So we're letting a be our independent variable, and b is just an arbitrary constant. And we're going to define this for a and b greater than 0. All right, so our next step is we will evaluate our function of a at the point a is equal to b. And if we do that, you can see that the entire integral evaluates to 0. Next, we'll utilize the Leibniz rule for differentiation under the integral sign to find the derivative of f of a, or f prime of a. So all we have to do is bring that differentiation inside the integral sign as a partial derivative. So we have f prime of a is equal to the integral from 0 to 1 of the partial with respect to a of our integrand. So next we're going to compute the partial derivative inside the integral. And if you take the partial with respect to a of this expression right here, you'll get x to the a. Okay, so now we have that f prime of a is equal to the integral from 0 to 1. We plug this x to the a, because remember that is our partial derivative. We just replace this with x to the a because that's what it is. So our f prime of a is equal to the integral from 0 to 1 of x to the a dx, and that's a very easy integral to evaluate. It evaluates to 1 over a plus 1. All right, so now we're going to integrate f prime of a to get back to f of a. So doing that, we find that f of a is going to be equal to the natural log of a plus 1 plus our constant of integration. And we can solve for that constant of integration like this. We know that, don't forget, we know that if we evaluate f at b, we get 0. Remember that from up here. So we evaluate that at the point b, and we find that 0 is equal to natural log b plus 1 plus c, implying that c is equal to negative natural log b plus 1. So substituting that back in for our c, we get that f of a is simply equal to the natural log of a plus 1 over b plus 1. So finally, we have our formula. All right, guys, I hope you enjoyed that, and we will see you next time.